Hello, what's going on? What's going on, people? This code could use a couple more comments. So scan DD is the breakpoint that I can set. Where we go when we have a percent, and I believe that we want the third one. Yes, the LLX. L, L, X. What the hell does L mean? Okay, this is the problem, is Nintendo 64 here has garbage in the upper bits. And I don't understand why. Is there something weird? Okay, guys, so what's going on is I was using, for the bytecode printing, I was just printfing it to standard out. And I was using the C standard library printf, and that worked fine. And then I said, well, I should put it into a buffer. And we have a little printf function that goes to memory. And that uses a different printf implementation, which is stbprintf. So I was like, hey. And when I started doing that, when we print our 16-bit numbers, I started getting CCs in the top, which is not correct. There shouldn't be CCs. So I'm like, why are there CCs? Now this is very weird because this is a little endian machine. So it's not like the memory location is wrong. It's like when this thing gets put into varargs, it's literally only 32 bits, I guess. You know what I'm saying? So like, is there something about varargs in C or C++ where things will get casted down from 64 to 32? Because it's definitely... Oh no, maybe it's not. Maybe this is 32. Maybe this is going to be an easy Bugsnax. Okay. This is a thing where definitely warnings would be helpful. This is why you want a programming language that's type safe about print functions. Okay, so we've been passing an S32 all along. It's just that with regular printf, the compiler probably inserted a help. All right. The compiler probably inserted a help and didn't tell me that it was doing that. It's very easy to change allocators. There's videos all over YouTube that tell you about it. Somebody could probably link you the playlist. All right, it looks like we fixed the Bugsnax. See, the stream is already living up to the title. I want to line up these comments now. What progress on the x64 backend bug found yesterday? I don't even... oh, none yet, because we just started. That is going to be one of the other Bugsnax that we're going to Bugsnax. But before going to bed, after noticing that, I noticed this one. And I was like, I can't keep adding bugs to the bug stack. So I haven't even checked in since last night yet. But I will soon, because we got this. It's just... Now I want to do the comments. Okay, because it used to be, we have this variable count. Let's just say, okay. Now, what did I just do? Base. All right. That Bugsnax is now Bugsnacked. Oh, yeah, somebody linked you to a good video. That is a relevant video. I think the current number of beta people is about 55 is the correct number. Maybe it went up to 60. I don't know. What makes people get booted out of the beta? That has not happened yet. It may happen someday. I want to refactor some stuff into one file, and then we'll check in. That's no longer true because we're using stbprintf. And put that there. Is it mainly driven by my experience in game programming? That's what I'm using to keep things real. Yeah. It's what I'm using to evaluate whether something seems like a good idea. Okay. Bytecode dumping now goes into a string. Now the question is, do we want to make more gains before we fix this other thing? And I think the answer is no, because the title of the stream is Bugsnax. And the people need their Bugsnax, I think. Otherwise, it's false advertising. What else did I do? Did this... I think there was other stuff that was not checked in. No. Oh, remove emit call of using function. Okay. What else? That was just factored because printing got moved. That's printing. This is related to printing. Okay, so we did a lot of stuff related to printing. Then that would mean it's mainly your own experience. What else do people have to work with? Has there been a case that someone suggested a feature and it wasn't something you didn't have experience with? The beta is not really driven by user feature suggestions right now, simply because the programming language is really pretty big and has a lot of stuff in it. And it's mostly right now people getting to grips with what's there and or making comments about the things that are there. There's not very much of like, you know, you should add the spaceship operator or whatever. And if there was that, I would probably get annoyed with that person. That's just not what the beta is like. Were these the missing volatiles in STB sprintf? I downloaded the very newest STB sprintf. So I don't know what... I don't know what you mean by missing volatiles. That's not what I was saying. Okay, back in a second. Let me get my tea. Okay, we will let that steep for a minute. So our next Bugsnax is the camera bug that was discovered last night. So let's repro that. Wait, did I not hit the commit button? You've got to hit the commit button or that will become a Bugsnax of its own. Yeah, we didn't. Okay. Okay, so Bugsnax. It was a comment next to define STB implementation. It said something missing volatiles reported to Jeff. Okay. Well, we're not using this in a multi-threaded manner, so I'm not going to think about that right now. It might indeed be something I should think about, but I am not going to currently. Okay. Now, if I go to local.variables and I say Bardstone test, which starts with a B the way Bugsnax does. So when I start this, camera's going to be too far out. Why is the camera too far out? I don't know. It seems to function correctly. It's just really far. And it doesn't feel like an FOV being radically off problem. I mean, it might be. FOV is weird, but it really feels like, well, yeah, I don't know. It really feels mostly normal, apart from the distance. If we go to Heroes 1-1, this, however, looks fine, I think. So what's the deal? And then if we compile with the LLVM backend, which of course takes longer, this is still far. Oh no, sorry, this is not too far, right? Let me go see the near plane distance and stuff. Oh, guys, it is. It's like the clipping plane is much closer to the camera. So I don't think it's distance. I think it's FOV. I think it's something with the setup of the projection matrix, which means it's probably a floating point operation. Okay, but what we can do is we can run this in the debugger from both backends and try to find what's different. Maybe we even do them simultaneously. Let's try that. We're going to have to rename one because I rewrite them into the same spot, but why am I looking at a giant folder full of junk? Build x64 debug. Oh no, that's the compiler. That's why. I'm like, wait. We're going to rename this to LLVM. Okay, and then we're going to build again with the other backend. And we're going to rename this one Soco Debug Bugsnax. All right. Okay, so on the left, we're going to have LLVM on the left hand of Christ here. No, Christ is not on my computer screen. That is not how it is. Okay, so there's that. Now let's just find a place. Maybe like in camera. We'll have like update game camera. That seems good. Why is it saying exclamation point? Windows Defender Firewall doesn't like Soko debug LLVM. It's recompiling all the shaders. Why? I don't know. Okay. Why did it not load the source code? So much for my renaming things. Can we not do that with Visual Studio? What's going on? Did I not rename the PDB? It's right there. Oh, it's looking at something. It's looking at something in the executable. It's being a poop, guys. It's being a poop. Let's try. I mean, let's try naming it back and make sure. All right. This is like, just things like this are why everybody doesn't like, this is why everybody's scared of low-level things on computers and think that they have to program in Python scripts and use LSP, because some things like this are just broken in completely unnecessary ways. Like, why can't I just rename those files and have it work, guys? Like, what the hell? It's just like, nope, low-level system thing. It's just going to mysteriously break. You don't understand why. The tool that can't find the PDB file is not even going to tell you what file name it's trying to open, because fuck you. You think in the PDB file there's the executable name? Yeah, there is. Why? I mean, for informational purposes, sure. But that prevents you from ever moving anything. Whose idea was that? Why, if you made the IDE, why, if you made the advanced IDE that teams of people have been working on for decades, would you not at least fall back to looking for a PDB in the same folder with the same file name? Explain that to me. Oh no, we can't find the PDB named in the executable. What should we do? I know. Let's hire 17 more people to do Visual Studio Team System features so that me as a manager can get my name on a feature bullet point and I can get a promotion. And then maybe I can go work at a company like Apple instead of Microsoft, right? Okay. Anyway. This is a total garbage. So we're not going to be able to run these side by side unless I deal with this link line garbage. Anyway, okay, before we worry about running them side by side, let's just find where we want to look at it, one of them. Okay. This is interesting how we just override these things now. It's like, okay. I mean, it could be this simple. Okay. FOV vertical is 0.6108. FOV, or Z near, and far are 0.2 and 200. It might be that I screwed this up somehow and we're getting these. Like, is Z near default? Is closer. That doesn't seem right. Okay, anyway, let's then keep going. At some point, we make a matrix out of this. Let's check the camera position. No, that's probably enough. That's probably fine. Okay, the orientation is fine. Okay, where do we actually make the matrix for this? What is the no one can tell you what the matrix is. You have to see it for yourself. Player control. No, that's the input. Obviously. I don't see anyone who uses this. Maybe it's an editor. It might well be. For all I know, this moved into the shader or something. Yucky. General 3D. Nope. You know what? We could look for like free cam. Okay, game camera mode is equal to dot free. This isn't supposed to be the hard part. I'm just looking for the camera. Okay. What the problem is, the rendering system got pretty much completely rewritten. And I'm not familiar with how this data is used now. Like, who uses the camera? Viewpoint. Init viewpoint proj. There we go. Now the problem is, this is going to be confusing because there's going to be probably multiple calls into there, because we're probably setting one up for the shadow matrix. Init viewpoint proj. Okay, so I'm writing down to fix this up. I don't want to edit anything else right now while we're debugging this, but like this redundant sets is of course silly. Probably happened by deleting some code that was between one thing and the other. Proj without fix-up. Okay, how do we know where we are? This is fluid sim. No. Reflection main. Okay. Maybe this is the right camera. Let's look at the position. That seems right. Z near 0.2. Ah, that's right. We know about these. Z near, Z far, and FOV vertical are exactly what came out of that camera that we wrote down. That's good. Okay, so we can get down here to projection matrix. Come on, it's a global and we're not outputting it correctly. All right, hold on. Proj without fix up and fix up. And I'm just going to copy and paste these factors into a file called matrices.txt. We're going to say LLVM version. Okay. Pretty straightforward. Hopefully one of these will be the problem. Now we restart with the Bugsnax version. Camera's too far. Good. Okay. So we're going to start that from the debugger. It's fluid sim, fluid sim, fluid sim. We actually clusters build. Sun shadow, reflection, main. I'm looking at this line down here. Okay. Z near, Z far, FOV vertical does not look correct. Let me just run for a few frames. Like, that's pretty weird. Okay. Foam buffer, data, clusters, sun, reflection, main, yeah. FOV vertical is trash. Not, well, it's not trash. It's kind of a reasonable number. Okay. It just didn't work, guys. This assignment did not work. You know, when you're in high school and they give you a homework assignment and you don't do it? I mean, you might not know that, but that was my whole life as a kid. So it's just putting the wrong number. It's maybe putting this number. I think our register allocator is not heeding. Okay, so the thesis is if I just get rid of this line 140, or if I just do this, the Bugsnax will go away, probably. Or it will change in character. Ta-da! Right, that's closer in. We'll put it back. Ta-da! Okay. Now, we get to use our new dumper code and look at this. And this might give us reasons to augment the dumper to be more intelligible, because this function's pretty big, but we'll see. So we build x64, and we want to look for line 140 starting around there. Oh, we need debug compiler to get the line numbers. We could put line number info in basic blocks. Anyway, maybe we'll add more debugging info. Because this would be cleaner on the left if it was the same file in line as the previous line, we don't print anything, right? Okay. So, well, we were looking for line 140. This is going to be... Well, some stuff happens. All right. So here are the constants for the floating point numbers. So this gets const expr reduced to a constant, as does that, as does that. So then, well, and then this one, I guess that's tau divided by 360. I don't know. Probably. But we get these floating point constants. Okay. This is going to be reading control.fov vertical. What we really need is some lamp power now. We all need some lamp power. Okay. We're doing a floating point multiply. As you expect, that's control.fov vertical. We're loading other fields. These are going to be the z near and z far, right? And then these are for writing to the struct right here. And these instructions are silly because we should just be able to do v46 plus 28, v47 plus 32, etc. That's something we can look at to make gains later. But, so this is going to be the first field, VFOV, and we're taking V7. Oh no, that's the L value. We're putting V41 in there. V41 is this first constant, okay? It is not this down here. Wait. Actually, no, because we rewrite it down here. We say V41 is this. Then we bin op it with this. 44 times 45. That seems right. So maybe, so this part, yeah, this part looks fine. So let's look at the x64 that comes from this. Okay. So we move R10 from some value off the stack. Whoops. I hate being in the wrong window. Like my cursor was over here, but all right, step. So R10 I don't know. I don't know how to view this as a float. We're adding 1 to it. Or 1C. Oh, this is the L value. Right, that's the L value. Never mind that we're writing it out. That's just the back end being stupid right now. So R10 is getting R8D, which is this hex float here. So Y okay. When we do a float operation, we need to spill any int register that we think, or not even spill. We need to invalidate any int register. Yes, okay. So the deal is, this was living in an int, and then we modified the version, but it lives in a float register, and the x64 backend doesn't really, like, float registers are not really a thing. So it's in memory. And so we just need to force it to read back from memory for now. Sometime much later, we will do good code gen from there. Okay. Duh, guys. Okay. Invalidate any mapped machine register. So, no. No, we're still in calling convention stuff. Print float bin up. There we go. Invalidate any mapped machine register. This no, not register. Yeah, register result. Okay. There we go. How do I describe this? I'm kind of amazed that this didn't break more code. All right. Really, it's any move XMM to memory. This is floating point negate. Okay. There we go. I believe we have eaten the Bugsnax. Damn it. Why have we not eaten the Bugsnax? Oh, because I ran the wrong compiler, guys. To succeed in the Bugsnax industry, you need to run the compiler that has the fix that you just made. Ta-da! We are now succeeding in the Bugsnax industry. Look at all these Bugsnax. Look at all these little Bugsnax. Just snacking by. Okay. Fix an x64 backend register allocation problem. Let's put that in the change log. Fixed a bug with the register allocator, with the x64 backend register allocator added in beta 044 that caused incorrect values for some floating point numbers in some cases. Incorrect results. Whatever. The Bugsnax is a real cool place where we can get together. Okay. I wanted to go to Sokoban program. And first I'm going to revert my dumps that I added. Okay. Just fix a couple of little things now. We can get rid of these. I mean, they were useful in that they exposed our bug, but that is not necessary. In fact, this is not, this is all just like code that probably used to be a lot more complicated, and now, like, what are we doing, right? What are we doing? Okay. Second, let's clean up some game camera mode stuff. So we could just say .free here. And we could say .free here. And we could say that free here. And we could say here. And there. Okay. Less code. Less code, better code, often, usually. Great. The camera's at the proper distance. We like it. I like it. Oh, that's not. Probably merge conflict. Let's see. Let's see. Tweaks. Yep. Let's just update the whole game and throw off all our numbers. Because now our numbers that we've been measuring for gains are going to be different because other people are editing the source code. But that's okay. We're not striving to be precise. We can close this other debug situation here. I can delete my Bugsnax copy, which wasn't ever going to work anyway. Okay. Let's make sure it still compiles. Good. Good, 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 good. Boom. Okay. This is very good. How are people doing this morning? What? Oh my goodness. A lot of people are awake in chat right now. What is going on? I think since we ate the Bugsnax, I think maybe we get to make some gains now. Let me see if there's any other priority 1 Bugsnax here. I don't think there are. I think everything to do next falls in the category of making gains. So let's edit the stream title to reflect our new reality. Okay, so an easy gain. Okay, let's see where we are since we updated the code and just edited a little bit and stuff. Let's see how many pull-ups we can do right now. I mean, not exactly, because the lower the number is, the better. Okay, so 400,851. 400,851 nanoliters of harmful muscle byproducts are being generated. We want to reduce this number to get under 400K. I'm going to write it down. We will, I think, easily get under 400K with the next gains. Because there's an easy gains that I didn't realize we had not picked all of. What's a basic block? A basic block is, okay, if you're going to do analysis on some code. Oh, let me go back. This has been our traditional thing that we dump. So if you're going to do analysis on some code, that involves looking at all these instructions that get generated and trying to reduce them. Like, hey, are there smarter ways with fewer instructions to do these things? And that's the optimizer's job. And to do that, the optimizer has to look for exploitable patterns. And it has to reason about them. It has to say, hey, if I change this thing into this other thing that's shorter and better and should run faster, is that going to break the program? Or is it going to result in the same program functionally speaking? So it has to be able to look at the code and reason about it. And one of the things that makes that confusing is when there's go-tos in the code, which in assembly here, ifs and while loops and for loops all turn into go-tos, right? So code has lots of go-tos in it, naturally. And those are hard to reason about because, like, let's say way up high in the program, a variable got set to a certain value, right? And then you're down somewhere lower and you're like, hey, wait, do I know the value of this variable? Can I get rid of this comparison because I know this variable is greater than 0 because it was set up here? Well, maybe you know that. Maybe you don't know that because maybe you got to the current comparison by go-toing over the thing that set the variable to the value that you want, right? And so you need some structure for being able to tell if that happened or not, and basic blocks help you with that. So basic blocks are a chunk of program code. Well, this flavor of basic block, because there's 2 different flavors at least. This flavor of basic block is a chunk of program code where the only go-tos in the program go to the start of it, right? So like anytime a go-to goes anywhere, you break the code and say a new basic block starts here and goes down, right? So now that at least gives me units that I can reason with. So if a variable gets set to a value up at the top and I'm down toward the bottom and I use it, I know that the only things that could have modified that variable are inside this basic block. I don't have to search the whole program and stuff, right? And then if I did want to search the whole program, I at least have this organization because I know what basic blocks could go to this one and where this one can go. So you can do like a graph search to see who affects this value, right? As opposed to just looking at this giant mess of instructions and trying to reason about it. Hopefully that helps answer the question. You feel like this explanation should be a clip? I'm probably going to do a full video on this stuff later, but it might be like a year from now. Because there's all sorts of things. Like the way, for example, that SSA usually gets explained is totally stupid and bonkers. And I want to fire everybody involved with the whole history of that. Any other questions about that before we move on and make gains? I'm ready to make some gains. I am ready. I'm ready. So I said there are multiple flavors of basic blocks. This kind of basic block that I'm implementing right now, you're allowed to have a go-to that comes out of the middle, right? And I don't break that into another block. Often when you read compiler books, the way they do it is any go-to in or out creates a new basic block. I might switch to that kind later, but for the purposes of what I'm doing right now, only breaking the program on incoming go-tos was enough. So I'm trying to find an example of an outgoing go-to. They're not going to be super common. And in fact, for if statements, I actually make an extra basic block right now anyway, because I'm a bad person. We might get rid of that and see if we make more gains. That actually might give us gains. Interesting. Yeah, we might get gains. You guess the jumps out won't matter for local optimizations? Well, it depends what kind of optimization. For the kind that we're talking about right now, which is just, did this variable get set to something before it got to me? Jumps out don't matter because if you jumped out, you couldn't get to that instruction, right? And there's no way to jump in after the jump out because that, if there were, that would have been a different basic block. How do you know how much granularity is enough? It just depends on what optimizations you want to do, like I said. Is this the type of stuff that teach in a course about compilation? Yes, but so every good compiler class at college level, which is probably the only kind, will tell you all about basic blocks. Like that's just a thing. That's a standard thing that got figured out many decades ago. It's a highly successful way to think about programs. It just works. However, it'll also, a lot of the other stuff you learn in that class is going to be BS that's stupid. And even the way that you learn to think about basic blocks is probably encumbered by a lot of baggage that is not useful. So it's unfortunate. I mean, yeah, I don't know. It is what it is. Four simultaneous live streams. Wow, that's pretty good. It's pretty good. With our tiny beta community, do I see myself ever becoming a professor? Not at a university. I could see starting a school outside the normal system. That would be fun and interesting, but like at an actual university, no. I don't even have a bachelor's degree, guys. I quit school because I couldn't handle it. And one of the dirty secrets of academia is if you do not have a PhD, so forget even bachelor's or master's, if you do not have a PhD and you get a teaching job at a university, everybody knows it is open season to poop on you all day, every day. To just treat you like dog shit. Like every single person I know who did that gets treated like dog shit. It's super disrespectful. So I will, not only will I never do that, it makes me, it drastically reduces my impression of how good the current university system is because they do that. Because they take good people and disrespect them heavily over qualifications that actually don't really matter. Like it's terrible. Okay. Is there a particular person or resource that I attribute my filter to? No, it's just I've been doing this for a long time. And if you do something like this for a long time and you have standards, you'll develop opinions, right? Okay. So, our current, well, we just went up here for some reason, right? Weren't we at 400? I wrote 400,851. Oh, there's some variability every time. I kind of don't feel super good about that, but we'll debug that at a different time. We've got about 600 instructions of variability. Disparaging higher education is no good for anyone. I don't know. I mean, you shouldn't let a decaying institution have a monopoly on the idea of what education is. Respecting knowledge is different from respecting the university system, especially if the university system is no longer proving itself to be the bastion of high quality knowledge. So all right. All right. So the gains that we can make are one very easy way to apply this value propagation throughout a basic block at emit time. So what the whole category of things that we're doing right now is emitting better code in the first place. So these instructions that you see here are what's directly coming out of the code generation of the compiler before any optimization passes happen on it. In fact, there aren't any optimization passes that happen on these. When we generate optimized code right now, we just hand all this stuff to LLVM and say, hey, you deal with it, and then it generates our optimized build. Now, it's in vogue in the compiler world that what you do is you just generate tons and tons of these instructions that are messy, and the back end cleans it up. And the reason why is because, you know, you could put optimizations in the front end, but they wouldn't obviate the need for having similar optimizations in the back end. So it seems like bad design to have it in both places. However, modern compilers also run like crap. So like you have to start questioning the decisions they make. And so what we do is we try, we don't put forth heroic effort to generate clean initial code, but we put forth more effort than compilers currently do. And this also means that when you output code for a debug build, that it's probably cleaner and makes more sense, probably. And that we can generate things faster. So one of the things that we are doing is sometimes you want to output a constant. For example, here or here, right? If that constant already exists inside your basic block, you don't need to make another one. You already have it in a value number, and you can just reuse that value number. Actually, you could go even further than that, and you can say if it already exists in any basic block that is what called dominates your basic block, which I'm sure is terminology that's going to have to become controversial and be changed, but we're not at that point yet. But because our current code just wants to be as fast as possible, we're not even doing that. We're just doing the current basic block. And that gives us some substantial gains. Especially because there's lots of times, like a constant like 0 or 1, or floating point 1, like your program probably wants those a lot, right? And so we catch those as we emit them, and it drastically reduces, well, not drastically, but it significantly reduces the mess of this kind of output and makes it easier to follow. Okay, so the thing that I realized is there are a lot of times when we're still generating constants that we aren't using that cached constant system. And that cached unlike the scary stuff we were programming last night, the cached constant system is pretty simple and should not actually malfunction. So it should be easy to make those gains by spreading it everywhere. However, that said, the x64 backend bug was probably related to that. Well, it would have been there without the constant sharing, but it was exhibited much more readily by the constant sharing. So in that case, actually, the constant sharing is good because it helped us find our bug. Okay. So, let's do that. These are all going to be in bytecode builder. And we're going to say assign to big constant. And this add emitted constant is the thing that we want to call. So an example of someone using this, find or add emitted constant is what we want to call. So like this thing, for example, is saying, hey, we have a constant. Here's the type. Here's the value. Maybe generate an instruction or maybe get a reuse value number, right? So in theory, we want to do this for everyone who uses this instruction, maybe. And sometimes it's probably not going to matter, but it might. I'm actually not going to do it here. Since it's not so likely to reuse this constant and the small speed hit to 100% of functions is probably not worth it, but we can revisit this decision later. Okay, so when we're outputting a source code location, definitely we could do that. So we want to say line number register is find or add emitted constant site arrow L0. And we're going to leave the old code here in case something breaks. Similar thing here, character number register. Site arrow C0. And just like that, we just want to keep doing this. This is for these pointer masks, which is used for relative pointer manipulation. I almost goofed on that right there. So if we're doing a lot of relative pointer operations in a row, now we will reuse these constants. We're not using a lot of relative pointers in Sokoban. This is, for fixed length arrays, the array dimension. Right. So, whoops, both of these. So the count register is S64 and source type array dimension. And then 0. I mean, again, just like I said, 0 is very common. Wait, we weren't doing anything. Oh. Hopefully I didn't break that. We'll see. Okay. All right. Did we get gains? We were in the 401, 400 range. Well, very small gains probably so far. I was hoping for bigger gains, but it still runs, so that's great. It's interesting, debug build is now at 60 FPS, which might be the renderer update as well. The guys have been working on the renderer. So here, oh my gosh, guys. Yeah, something major improved. Because we were like around 15. Now we're at 17 FPS. So yeah, maybe that's renderer, but maybe this code gen stuff that we've been doing really helps in, and that's for the debug build, by the way. That's not release build. All right. So I'm going to run the tests on this. And then we'll take out the no check-ins. And then we'll keep making gains. If the array dimension is known to be 0. Oh, that's a good point. Good point. That is not really going to reduce the number of instructions, because what would happen is this would just return that. But it means we don't have to look for a 0. It means we know that we have one. So it's slightly faster. Not in a way that anyone's ever going to notice, but but there we go. We're going to run the tests again. Instrument code, use profiler to know exactly what to improve. No, we don't have time for that shit. We're improving things at a very fast rate. The last thing I need to do is sit around for a week profiling things in order to figure out exactly what got faster. No, we're making things faster over and over and over and over at a rapid pace. We don't do pair programming around here. We make gains. That is what we do. You're in the house of making gains. All right. We have gained our way all the way from C++ to our own new game engine in our own new programming language. You don't do that by being slow. And even then, it took a long time, but you don't do that by being slow. All right. How long does it take to make a profiler? I mean, we already have a profiler. That's not the issue. Why was I clicking on this? What am I even doing? Oh. Use constant. I would describe those as marginal, but we might hit one that's big. So we're just going to keep looking for assign to big constant. There's another 0. For strings, this is like casting a string to, to a C style string. I also should run an LLVM version because LLVM is more picky about casting and will complain more readily. Okay. Now, a thing about this is it actually won't reuse this 0 if there's a bigger 0 for reasons. Because that's how this thing knows how many bytes to write. But, you know, the peephole optimizer can do that part of it. Okay. This is emit declaration. Oh, geez. Yeah. Okay. Oh, no. We actually don't want to do that here. We actually don't want to do that here. Okay. Here's another array dimension. Emit array base and count. Okay. I need to get better with the Emacs kill ring. What is it? You go control and then meta Y? Yeah. Oh, yeah. Okay. I know how to use that. Oh, no, we can't use this again. Okay. Whoops, that's not what I wanted. 0 register. That's for a for loop that goes opposite. hold on. Okay. Okay, so zero register. We don't actually want to do that. Again, because this is reused and changes. Wait, no it doesn't. No it doesn't. No it doesn't. What am I talking about? Let's just see if we made any gains and or broke anything. $40851. We're back. We got another few hundred gains. Well, maybe not. Maybe we didn't really get any gains. Hardly. I was hoping for more out of these. We've still got some left, but I was hoping for more. What is this? Emit struct dereference. Zero register. Null pointer. Okay. Dude, Emacs sucks. All right. So we get a zero register. We set that to R value. I don't like what I'm seeing here. Why are we setting the dimension? Oh, this is the data pointer, right? Yeah, okay, I don't think that can currently happen, but... All right. Array bounds check for the array length. This one might give us some gains, actually. All right. Let's try these out. Did you miss the Bugsnax? Well, We might introduce new Bugsnax that then need to be snacked on. $399,794. We are under the 400. Look at that. Does it run? Yes, it does. Let's run the tests. Why is it varying while compiling the exact same source code twice in a row? Well, compilation does happen out of order. And so things come in different orders. Now, that shouldn't, in principle, really change anything. Except really that the meta program might do something different. Like, I don't know. Definitely that should be investigated, why it varies. I just don't want to derail and do that right now. How often do I find myself using polymorphism, both static and... What is dynamic polymorphism? What? Okay. We're also making gains on code size, by the way, I will point out, because we're replacing these sequences of several instructions with one instruction. Not big gains, but yeah. Okay. Another 0. Wait. We're not actually storing this 0. We were just generating a 0 for no reason. The value of the register is the pointer to the base. Oh, never mind. Okay, no, this was correct. You know what? I'm going to loosen the criteria about what we allow ourselves to reuse. That by itself might make us some gains. It might break things horribly. Hold on. There we go. It breaks things horribly. Um, all right. We got a little bit of gains. A little bit of gains. Let's see if we can drive it down to 398. Next. Whoops, didn't remember to delete that code. Okay, placement. Plug register. Yeah, okay, so this one we don't actually want to use it. Because this is like, yeah, I already have a note here about why we don't use the emitted constant. Yeah, we'll check that later. Code directive. That is a pointer. I mean, I guess we could share those, but I doubt it. Zero register. This is probably a rare corner case. That's it. That's the last one. All right. Do we have gains? We got an extra 50 gains out of that last one. Oh, wait. Except maybe more, because I mean it's fluctuating, but we're doing okay. So we're around 3995 somewhere. 3994. I'm going to write that down. So since we finished with the Bugsnax and started making gains, we started at around 400851. We are now at 399417. So that's about 1440 divided by 400851, which is 0.36%. The improvement in code size, which is not by itself a giant gain. But again, if you could do that several times in a row, and then do that several times in a row, and then do that several times in a row, you've got real gains. In find or emit caller location, you had emitted caller location site equals old site. maybe that was fixed. I don't know. This looks right to me. Above the return in this? Oh, yeah, no, yeah. Oops, that was a bug. That was a bug. The Bugsnax just keep coming. Okay, that is done. Boom. So done. So good. Okay. Let's check that in, and then we'll see if we get gains out of removing the superfluous basic block on an if statement. Okay. 504,850. We have staved off the peril of hitting the 55,000 point a little bit further. Just a little longer. More constant sharing, period. We'll do a quickie release build. We'll just run this again so we can see our nice gains. Look at our nice gains. Release build doesn't print that number. It's fine. Now what? If statements. No. These names are confusing. We'll change them later. Oh, this is to skip around the else block. I see. Okay, I've got to do some surgery here to prep for one of the future things we're going to do. So if we have an else block, this is made more confusing by the fact that I'm getting rid of the then block. I want to get rid of this. Which we're going to get rid of this BB index stuff. Okay. Okay. It's not called first instruction index. What's it called? Oh, it's a function. Get the first instruction index. Okay. Well, we can't see if there were gains. We didn't really get any gains here in our main from that. But that doesn't mean we didn't get any in the program. Let's just make sure it runs. How many basic blocks? I guess we have fewer basic blocks here. Because before, do we have it in scroll back? We had 8 basic blocks, and now we just have 6. So that'll be more readable in the short term. Let's see if we got any gains. Oh my goodness, look at all the gains. We got 1% gains just from that. Have I noticed any compile speed change? There has not really been a compile speed change. So right now we're a little bit slower because Windows console output is slow. But I think we're actually faster overall. So if I turn off this dump, where is it? It's here. If I turn off this dump for a second, we're at like 6.7 right now, 6.8. And usually, as I recall, we were at 7.0 to 7.3 usually for x64 backend, if I'm not mistaken. But it's hard. Again, that's with like OBS running and all this stuff. And it might have been every once in a while I go to my task manager and notice that like the monitor driver is eating an entire core. So it's a little bit unscientific as to what these numbers are. But this is not noticeably slower. I'll put it that way. I think it's a little bit faster. Would a profiler give more accurate times? What do you think this is? How is a profiler going to do something besides tell me how long things took? Is the witness blog coming back? Make the web stop sucking and the witness blog will come back. You thought I'm checking time? Yeah, I just checked time in my program. That's what this is, time checking in the program. People tell you measuring time like that is less accurate than using a profiler. I mean, I don't know what they think a profiler does besides tell you the amount of time. Compare day to day for regressions and improvements. No, I don't have time for that shit. Again, this compiler, the goal, okay, right now, this compiler is doing, in the part of the compiler that we're responsible for, 0.67 seconds, right? Or 669 seconds. It would be faster if we weren't streaming, but we'll call it 0.69. So we're doing 149,163 lines of code divided by 0.69. We're doing 200,000 lines of code per second. The target is 1 million lines per second. I'm not going to waste time fidgeting around about did we get plus 0.3% speed today because blah, blah, blah. Our target is 5x off where we are today, okay? That's just different. You don't like waste time obsessing about things that don't matter. Right? Our goal is that this number is 1 million. You'll be able to tell the difference if this number is 1 million or not, right? Like I'm not worried about if this noise is whatever, right? It's 1 million. Or if you use the more conservative lines of code number, I think usually when people say their number of lines of code per second, they're counting blank lines and comments, which makes Swift especially embarrassing. But so if you go the other way, right, 96597 divided by 0.69, right? So then we're only 140, and then we need like a factor of what, 7 point something. So we're between 4x and 7x off of where we want to be. That's half an order of magnitude. So like gains are going to need to be made. How much of is Swift? It kind of depends on your program. Maybe some other people here can fill in accurate. 1 million with how many cores? With as many cores as this desktop computer has, which is like 6. If the compiler is that fast, object files are basically useless. Correct. Correct. What key parts of the compiler do you want to optimize to get to 1 million per second? I think there's some low-hanging fruit. We could probably get almost 2x just by very boring optimizations. Because like I haven't even looked at performance in a long time. So we do that. And then if we can multi-thread more things, that can get us the rest of the way there. Especially if we could somehow multi-thread the type checker. The problem is that that's difficult and scary. But we'll see. But yeah, like I'm not going to fudge around. The goal is, like when we get to 1 million, then maybe I'll start tracking the performance day to day and look for tiny regressions. But right now, tiny regressions in performance don't matter because we're trying to get somewhere way far. It's like if you're driving around on the local roads. It's like if you're trying to drive to New York from Texas and you're worried that while you're driving around local roads to get on the freeway, you're driving away from New York a little bit. It's like, no, that's, you got to do that to get there. Okay, well, did I run the tests with the if statement basic block? I don't think I did. Let's run them on LLVM this time, and I'll get some tea. They're still going. We'll get better with C++ 20 modules, maybe, but that guy who quit the modules working group and posted about how he thought modules were going to be slow doesn't seem to agree, but we'll see. Yeah, so with about this terrain question, you're taking something people say and extrapolating it too far. Yes, you don't want to draw lots of small meshes. But you also don't want to draw a giant mesh with millions of triangles, most of which are not in the frame right now. Right? If you do the first thing where you draw too many small things, you're getting killed by batch overhead. If you draw a mesh with many, many triangles, most of which are not in view, and you don't have batch overhead, now the majority of triangles you're sending to the GPU are waste. So of course you're going to be slow. Okay. feel good about the gains that we have been making. I just like looking at the number go down. Number go down. Number go burr, but in the opposite direction of the usual burr. Okay. There's lots of other fun things we can do to make things better. I actually want to add a little bit more information to the basic block. We're going to say we're going to do this, and I had to put the dump back so we could see our dump. So I just want to put information for each basic block about what value numbers are defined. Okay. And then when we print, we're going to say if first shall be last, and the last shall be first. So we're just going to say in the output which value numbers each basic block defines. Oh, whoops. That is a printf. And it totally didn't do that. That's a shame. Oh, maybe the earlier ones do, and we're just not. There we go. Oh, we don't want to put the new line. Okay, so when we finish the last basic block, we need to do that. You know, we're going to put more information here, so let's just do this. Okay. So if you want to look up where a value came from, you can now see what they are. Okay, basic block 6 does define some new values, and the thing is we're not when we do the final basic block, oh, finish basic block. Yeah, so that's the only calling site. All right, so that should then put the relevant information here. let's take there we go. It's almost like a real compiler. How are things going, people? So now I think it's time to do the BB index thing. The BB index. It's like the BBC. But it's the BB index. This could get messy. But I want to do it. It's time to do it. And what that is all our go-to statements go to instruction indices. And we want to change those so that they go to basic block numbers. And I think the way I'm going to do it is by the time-tested technique. The triple T method, the time-tested technique of breaking the crap out of everything. This is, again, a power that you don't have in Python or JavaScript or whatever. We're going to say go to constant hello sailor. All right. And jump branch go to. Are those our only go-tos? Let's see. Go to constant, go to constant. Yeah, I think because we used to have 3, but now we have 2. Okay, so now the entire program will break anytime somebody tries to use one of these because those names do not exist anymore. They are now hello sailors. And we just audit every single one. That sound is that for some reason, even though my phone is on silent, my iPad decides to ring when the phone rings. Because Apple just like decided that that would be a good idea. And I'm sure I can turn it off. Don't know how to do that. Not interested in figuring it out. Okay. Well, go to constant if cc. This is now going to get a hello sailor. But that means now loop exit patch BC. Needs to get looked at. Okay. And then loop skip patch is also going to have that. Okay. Okay. So here we don't make a variable because it's embedded right in there. So here we say arrow basic block index. Interestingly, we didn't actually correctly tag that one BB index. BB2 failed us. Okay, so now we have the hello sailors there. 2157. Wait. Oh, different file. Let's do that just to get it off the top. So go to constant if cc hello sailor. This is from the other end now. Before we were writing this index, now we're reading this index. And I think from here we just say, for now we're just going to map it back here. New PC. I'm going to make this a really cumbersome thing. Do we have this variable? Do we have like current bytecode? Bytecode, okay. Interp bytecode index, all right? So this is going to get replaced later anyway with probably something more convenient. For now, we just want this to happen. That's a hello sailor. Okay. Okay. We get the basic blocks, sub basic block index, assert BB basic block index is equal to basic block index. This will no longer be true when we start removing vestigial basic blocks, so this will need to change eventually. Okay. Get okay. Great. X64 converter done. Back over here, 3310. We need some more hello sailors. Go to source BC. Okay. $33.21. Oh, wait. Oh, that needs a hello sailor. Emacs is so slow that it like takes a fraction of a second for things to come out of that kill ring, and it makes it almost something I don't want to use. Okay. Yep, same thing. Hello sailor. So go to first non-default case BC, and then go to after body source. I don't know about this one. I don't think we actually need this. But I'm not going to worry about it yet, because that doesn't affect what we are doing. Okay. Fuck you, Max, dude. Oh my god. Okay. This is go to if false source. I think we just did that. Nope. It's so slow. And it doesn't even have the... there we go. Oh, whoops. I passed it. Oh my god, this sucks. Just type it. Just type it. You'll be more successful in life. Oh, whoops. That wasn't even... Okay. Chances I will screw something up here are pretty high still. Okay. Source if part BC. Else part BC. Woof. Okay. We need to do this. Okay. And then this clearly made some gains right there. All right. Add patch. Add patch. So here we say there and there. Bruh. Making tiny gains everywhere. Okay, go to constant if cc hello sailor. Getting rid of the done withs. We're not really going to do things that way. These are empty macros that don't do anything. I'm going to write down to get rid of them. It's executive decision, but we're not going to really do it right now. Okay. What am I doing? Oh yeah, go to CC, short circuit BC. Successor. basic block index. Okay. Oh, different file. New PC is this. I got a new PC. It runs Tarkov real well. Oh. All right. Bytecode printing. Here, we just print the same things. So we just hello sailor this. And people are going to just have to know that that goes to basic block indices. Now LLVM will complain. So we're going to hello sailor these. And we're going to have to clean that crap up at some point. Interp. $41.09. Okay. Ladies and gentlemen, for that even to work as far as it did, compile time execution had to run flawlessly. So take a look. Where's our jump instructions? Jump 6. This no longer means jump to instruction 6. It means basic block 6, which is down here. Let's find some other jumps. Jump 2. Boom. It's actually easier now to look it up because it's any jump point is like, you know, yeah. Can we find some jump F to 1, right? So that's basic block 1 down here. Does it blend? It does. So that was the x64 build. Let's try the LLVM build. So 2 out of 3 work so far. x64 works. Compile time execution works. LLVM, I screwed up. LLVM, I made a mistake. Somehow. I probably was just getting tired and too sloppy. I don't exactly see why it's different. We got a new PC. I don't see any other use of index A. All right, well, it looks like we have some Bugsnax to snack on. This is very weird because that doesn't look like a basic block error. That looks like a totally different thing. Did we change something else in LLVM converter? Notice how many of our problems seem to involve LLVM, by the way. New PC. True block is new PC. Okay. So let's just let's see if we can see the problem. Removing our breakpoints from before. Look at all these nasty honey badger breakpoints that we don't need. Oh, good. LLVM's just, you know. Oh, wait, no, we're running. Are we running X60? We're running X64. Let's not do that. Okay. Here we go. It's complaining about a poke return value. Is it possible let's see where this is. This could have to do with one of the other changes that we made. This doesn't seem like it has anything to do with basic blocks. It seems like maybe I didn't run a debug LLVM build after changing something else recent. Oh, you know what it is? I know what it is, guys. Here's my executive guess about what it is. Remember when I did this thing, when I widened the criteria for whether an emitted constant was acceptable. And it used to be this. I bet, well, I don't know how much I bet, because I feel like we did run LLVM after that, but let's see. That was it. Okay. I'm going to make the executive decision to run tests on this. I'm going to disable that gain for a bit. The problem is, so I don't want to randomize. The other big change that we did by working on something else in the middle. So we're just going to run the tests. And then we'll try to go back and figure that out. The problem is, because LLVM is such a butt about casting, it is quite possible that we would have to introduce a lot of casts. Maybe not. I mean, we already have a lot of casts. That was the debug compiler, guys. Debug compilers, debug executables generally in all of computers run slower than release executables. If you look on the screen and it says debug/whatever.exe, do not complain about speed, because it's debug. Look, you can't have the Bugsnax and maximum speed at the same time. That's not how it works. Okay. Okay, so that does seem to be successful. Let's build and run the game again, just to be paranoid. And then we'll have to get our gains back after this commit. I can't believe I did that without checking LLVM. That was a real Bugsnax. Okay, we still, I mean, this is pretty okay, if you ask me. Let me see if I have any more BB indexes. Probably do. Like there's that one. Oh, there's this no check-in. We're going to leave that. And then this one, let's comment this out and test again, because I am pretty sure that that does nothing, because when we create a basic block, we flag its instruction as a branch. So this just should have been removed before, and it didn't get removed before. Okay. Yeah, it's actually important for your debug build not to be dog slow. And that is something that modern compiler writers have lost track of, to their great detriment and to the detriment of computers, broadly speaking. It's really bad to have your debug build be too slow. At the same time, you don't want to run a bunch of optimizations on it because that's the point. So what that means is your compiler's baseline output has to be kind of reasonable. What kinds of optimizations do you want in the debug compiler? Well, we're not really putting any optimizations per se. What we've been doing today and yesterday is making the default output cleaner. Like an optimization is more like after you've output the initial code, you do some passes on it to rearrange the code to make it faster. What we're doing is making that initial output reasonable. Are there optimizations that I can recommend or caution against for opcode, dispatch, and a bytecode interpreter? No, I mean, honestly, I just have a giant switch statement, and it may or may not be that fast. I don't know. It's just not something that I've cared about yet. I really don't. I mean, obviously, you could do things manually, like a hard-coded binary search through the opcode space or something, but that's very branchy. But that still might be like you could do a binary search through the opcode space and put all the most used. You could do a histogram of your opcodes and make sure that all the most used ones have the same branches. You could do, it's kind of like Huffman coding, but for branchiness. The thing is, I want to arrange my opcodes in a different way for a different reason. So I haven't entertained that. Although the other purpose why I'm sorting them could be done with a level of indirection or a parallel table. So, and maybe that would be equally as fast for the purposes of what I'm doing. So I don't know. But that's not something that I've ever done and measured. So it could be a large amount of engineering effort for something that doesn't matter. Okay, so that no check-in is a gain. We have deleted it. Let's do a final release build just to have fun. Let's see. 865. I think we were at 8.5 something. So we actually went up a little bit, which is weird. All right. Let's check that in. BB index is done. I actually had 2 pieces of papers for this. Use BB indices in branch instructions. Okay. I actually have a note. Let's commit this. I actually want to refresh my memory about what something was and see if I can check it off. Okay. Base jumps. Now jump to basic blocks. That is very good. Very good. Very, very good. Okay. What I had something about line 641, which actually might have changed because we updated the program, but let's run the debug compiler to get our gains outputs. So line 641 had some code generation I didn't necessarily like. This is weird how we're setting the location weirdly for those. Okay, 641. Right. BSSL value. Yeah. Okay, so that's the same one. All this note is that like, hey, we're getting an L value, we're adding a constant, and then we're storing into that. And it's like this add doesn't need to get generated. And that doesn't seem like a big deal, but like we do it a lot. So that would be a good gain, but I'm not going to worry about it yet because I've got some other stuff I want to do. Let's make some gains in deleting the done withs since I just want those out of the source code. Done with, maybe done with, remove ref, known 0, all that is gone. Done with, done with, done with, done with, done with. I don't think we're going to need these. If we do, I'll be sad about deleting them, but not that sad. Yeah, it's just a little bit scary if I were to use that. We'll see. If these ever come back, they will come back at a later time. These all just came from, it was even like a month ago that I did this, or maybe a little bit more. And I was like just starting to think about how to do better code generation. And I was like, these might be useful, but I totally didn't end up using them. And there are actually a lot of spam in the code, and they probably rot very easily, and there's not really a system for ensuring that they're right currently. And it's like, just get rid of them. I hope done with L value info wasn't anything. Like, look at all these different flavors of done with I had. Known 0. All right, I probably missed some. Remove ref. Hope I didn't delete anything important. How many gains did we make there? Like 100. We made like 100 gains. All right. Now, I think we go investigate now. Okay. So now we go back to the debug compiler so we can look at our code gen gains, right? So now, without re-enabling that loose type matcher, we are at 397,549. If I go to re-enable this gain and do this, we are at 396,986. So it's like 570 gains, which is 0.1% of the program. But in some portions of the program may matter a lot more. Let's just see how annoying it is. Like, if it's super annoying, I'm okay not doing it. But so let's go back. We're going to run. LLVM is going to complain. We're going to try and cast that. And then we're going to see if it complains elsewhere. And then elsewhere. And then elsewhere. Who freaking knows? Okay. Like, I don't see any reason why this is particularly special. So, so do I cast the left value, or do I cast the pointer? I guess I cast the left value. If those are not equal, I almost know how to do things in LLVM now. You just type a bunch of spam. Get type. Oh, I typed it wrong. Why do I think that it's like that? No, it's like that. I typed it there and then there. See, my brain. Get element type. Oh my God. That probably won't work. Duplicate symbol. What? Oh, no, that's just, I think that's just what happens when we run it in the wrong folder. I think we fixed it. Sorry, LLVM. Let's see. Nope, invalid cast. Why didn't it do it up there? I don't know. Maybe it did and it just didn't break on the assertion fail. Oh yeah, because we can't do a bit cast if they're different. No, they should be the same size though. Let's just see. Let's just try to get it to complain. Oh, it's no jobs is broken. Really? When did I break no jobs for LLVM? Ah, this is inconvenient. This is giving us another Bugsnax. That's fine. We'll run without no jobs for now. We don't need it. Can enum have string underlying values? No. No. Okay. It does not like our bitcast. Why? V to dest tie. So this dynamic cast is failing, which gives us no information whatsoever. We are trying to cast a pointer to I8 into, I bet it's just an integer, right? Yeah. Into a 64-bit int. LLVM won't let us do that because LLVM is a fucking jerk. So Um, you need a pointer to inst. Yes. And that is what happens down in here if one is a pointer. But like, I don't want to have to type that out everywhere all the time. Hey, okay. That doesn't mean we won't have more problems in the future. But we'll see. Let's run the tests. Look at our gains, though. 397,134. That's how many push-ups we can do. Actually, no, because that number keeps going down. But I'm getting older, so... Yeah, I mean, there's no real serious reason preventing us from making a string enum type. It's just it's kind of bad style, honestly. It's kind of bad style because if you serialize and whatever, you don't want to be serializing strings. Probably. I don't know. Do we have a date that I want the language to be released? It is released to the beta testers. This isn't Bugsnax. Yes, it is. We've eaten lots of Bugsnax so far. I don't know what you're talking about. We have eaten so many Bugsnax. I woke up this morning, jumped out of bed and said, I want to eat some Bugsnax today. And that's what we've been doing. And then we also made gains. It might be time for me to take a break. We're going on 4 hours of the stream, and it's literally the first thing I did after getting out of bed. I can rewrite my to-do list during the break. So there's some more instruction cleanups that I want to do. Those could make a good topic for a later stream. Also, I bet if I look in the mailbag, there's lots of Bugsnax in there now. So maybe later today, okay, maybe the real thing to do is to do a stream later today where we go through the mailbag and then we just ship a beta to people with all this stuff in it. With all these gains that we got, and then plus whatever Bugsnax we can get out of the mailbag. And that'll be a good beta to ship. What mailbag? The bag of mail that people send me. Do I write a to-do list for each day? No, but as I work on things, in general, as I work on things, more issues come up than I can handle at the time. So I just write them on a piece of paper. This one's probably the last 2 or 3 days. Although if I'm working quickly, they do tend to get a little messy, and then I clean them up. Mailbag. Probably is mostly dudes in the mailbag. That is true. Any last questions about what we've been doing before I take a break? So we started before all the recent gains at 436,574, and we are now down to I'm going to have to fix no jobs on LOVM, I guess. We are now down to 396,995 or something like that. Yeah, about that. So that is um, 436,574 minus 396,995 is this, right? And we're going to divide that by the original number. It's about 9%. So we have cleaned up our instruction stream by removing not quite 1 out of every 10 instructions from the original input. And we display it much more nicely. And there's still significant gains. Actually, guys, after the break, I might want to make one more gains, which is this one. No, not that one. Sorry, not the index TT. The add-ins. I think that might be a pretty big gain. So if we can deal with that, the reason I sort of punted on that one a little bit, but I want to hit that one. That's like the last big gain for this beta. How's that? And then we'll do Bugsnax. How hard would it be to use this for your own custom-made RISC processor? Well, you'd have to target the processor's machine code. But that's a back-end only issue, so most of the compiler would still work. Why are the bytecode instructions count different between the two builds? We don't know. It might be a bug. It is something to investigate. Yeah, there's not really, most of the complexity of the compiler is actually in the front end, and the front end does not care about your CPU. That said, as we put more optimization into the back end, that will be complexity that you would want to reduplicate for any different CPU. However, that's optional, right? You can always do what I did in the beginning for x64, which was just output really dumb machine code with no register allocator. Like that strategy will work for anything. And that just gets you up and running on that chip, and then you can make that code gen better, which how to do that really would be different for any particular chip a little bit, because, you know, different chips are different. That's the whole point. And what is a good thing to do on one chip is not a good thing to do on another chip, right? But yeah, like if we can get rid of a lot of these add-ins, that I think that might be a 1% gain, and that would take us over 10%. Might be a 1% gain. It seems to happen with the majority of struct assignments, and there's just a lot of those in a program. So we will see. Am I looking to get married in the future? Well, I was thinking it was unlikely, but then, you know, I sort of know someone now who I might want to do that with, possibly. So we'll see. Let's see if we can raid someone. Who is a good raid target? Don't do it. It's not worth it. Well, it might be worth it if it's the right pairing. There's some blueprints or whatever. I can't tell if that's Unreal or Unity. That looks like Unity, doesn't it? Is that Unity boxes and lines? No, it's Unreal. So we could do some boxes and lines. I'm not seeing anything else. So, although this guy's doing Bugsnax, or maybe he's intentionally creating bugs. All right, we're going to do some boxes and lines, and I'll see you later. We already did Piggy Bank Studios just like 2 days ago. Thanks everybody for coming by. I'll be back later.